Hello students, welcome to Misostudy, and today what exactly we are going to discuss that is slightly different from your regular lectures. Actually we hope that till now you must have revised your this topic, that is electromagnetic induction, fine, EMI, a very important topic of class 12th for exam point of view. So we decided let's start the discussion of the questions based specifically upon JEE main pattern, fine. So this exercise is going to be continued. Every time we will come in front of you in a form of new videos, maybe 5 questions, maybe 10 questions. Idea is to give you an opportunity to check and revise your basics and also learn how to tackle the problems in actual exam conditions, fine. So motive over here not to explain the solution of the problem, no, not at all, but motive is to guide you how to read the problem, how to understand the problem, and then how to correctly reach to the proper solution, okay. So here one by one I will start this discussion, problems, explanations and so on so forth, fine. And don't worry, all the solutions of these questions is also present in your ebook. So at any point of time you can take a look of those solutions also. So this is your first question, fine. So what exactly the approach is? First we will try to understand the question, and then accordingly one by one we will provide the solution and check which one is the correct option. Now an electron is moving in a circular orbit of radius capital R with angular acceleration alpha. I think this line required no further explanation. If you just read this line, visualization is very easy for this, fine. At the center of the orbit is kept a conducting loop of radius R, okay. Now I think I should draw a diagram after reading this line, fine. The EMF induced in the smaller loop due to the motion of the electron. So first thing is that let me draw the diagram for this second line at this available space, fine. So for the time being, if the lines are not visible, just don't take pain. It's going to be like this way, okay. Electron is revolving and this circular is the loop, this circular shape is the loop. What exactly the cause of induced electromotive force? Obviously the circular motion of the electron, because electron has charge. And what is the charge of the electron? That you can easily mention by small e or q, okay. Now R is the radius of this orbit of this electron, and at the center is kept a conducting loop of radius small r when small r is very less than capital R. It means, imagine the situation, let us say this is the zone where this circular loop is placed. So electron is revolving outside like this, fine, this is the situation. So let us try to find out the solution of this particular problem. Obviously the formula we are going to use is simple result, that is this is equal to A d phi by dt, this result. So this is our basic result. Again and again we will use this result during the discussion of the problems, fine. So let us start this solution. E or this E or this V, any one may be the symbol, but in general we use this small e, fine, while the small is also the charge over here. So let us use this E, induced electromotive force, and it is A dB by dt. Now why I am writing dB by dt? Why I am not writing anything else? Reason is simple, that is minus d phi b by dt, basic. But phi b is equal to BA. A is the area constant, B is the value of the magnetic field which is varying, so that's why I am using this relation. I was not supposed to write down this, reason being this is a very fundamental thing, but with this assumption I am starting that few of you may have not revised. Fine. Now because circular area, so without any difficulty I can write down pi r square in place of A. Okay. Now what about this dB by dt? Try to recall the formula for the magnetic field produced on any circular point. Fine. So I am using direct result, but if you have any confusion, please stop the video over here only, revise that formula, then again start that. If you are regularly watching our videos, this is something which is very properly explained. Fine. And that's why I normally used to request all of you be regular with the concepts. Fine. So pi r square, then d by dt. Why? Because this v value is changing. So what I will do, I will use a bracket, that is mu naught upon 2r. I hope now up to some extent few of you may start getting the clarity of this formula, into q omega, q or e, let's use e as given in the problem. Fine. Yes, answer is in e. So e upon 2 pi. Basic result, that's why I mentioned it with the different color. Now imagine a situation, what is changing? Is it like that mu not changing? No. Is it like that E changing? No. 2r, 2 pi, everything is constant. What is changing? Changing is this omega. Fine. So let's try to arrange the terms. Is equal to pi r square. Then mu naught E upon 4 pi r as it is. Okay. So mu naught E upon 4 pi r, fine, into del upon, no difference, d omega by dt, delta omega by dt, something like that. It just showing that it is changing. Now students, go back to class 11th, and what is the name of this person? The name of this person is nothing but alpha, and alpha is given in the problem. Fine. Angular acceleration. So rather than using this blue white box, we will use this relation. So how exactly we can finally write down? We can write down induced electromotive force is equal to pi cancelled, mu naught upon 4 r square E upon r square E upon r into alpha. Now let's try to find out the correct solution. Fine. So mu naught E or this r square upon 4r into alpha. So B is the correct option. In this option, what exactly is not present? That is mu naught upon 4 pi. Pi is extra term, and that's why I use this yellow color chalk to show you that it has been cancelled. Fine. So if you properly solve the problem is very simple and basic one. Fine. So with this note, by proving that B is the correct option, let's move ahead for the next problem. But before that, I would like to clean this space so that we can discuss next problem's solution over here. What exactly the next question is going to be? A very curious point, I know that. So don't wait, just move ahead. Now, I hope entire diagram is clearly visible to you. Initially I thought I'll draw the diagram on the board using free hands, then I think it's much better point of representation. See, just try to understand what exactly mentioned. Actually these cross, they are nothing but representation of magnetic field which is perpendicular to this green board going inside. Fine, general symbolic representation. Let us start from there. A square wire loop of 10 centimeter this way, side lies at right angles to a uniform magnetic field of 20 Tesla. B value is given and side of this square loop given. A 10 volt light bulb is in a series with the loop as shown in this diagram. Simple. The magnetic field is decreasing steadily. Now, before that I would like to mention one critical aspect over here. For the time being, just hold on. Is equal to d phi b, b by dt, where phi b is equal to BA cos theta. Now, changing, phi b will change. If it is changing, phi b will change. If it is changing, phi b will be changed. It means out of B, A and this theta, if anyone is changing, then phi will change and induced EMF will come into picture. Fine. So, over here very clearly mentioned that magnetic field is decreasing. A is same, theta is same, but because B is changing, so obviously some amount of induced EMF is going to present and that will ultimately force the bulb to lit up. So, the bulb will shine with full brightness if delta t is equal to time interval, value of delta t. And what is delta t? Actually, delta t is that small amount of time in which magnetic field is starting from a higher value going to 0. Initially, let us say the value of the B was, for example, 20 Tesla as it is given. So, it is reaching to 0 in a very short duration. You have to find that short duration. Fine. So, again the problem is simple. I explained. We are going to use the formula and the formula is more or less similar to the question number 1. Fine. What is that formula? Is equal to A dB upon dt. Ultimately, theta angle is not important over here because magnetic field lines are this way and this is placed in this fashion. So, ultimately theta is not changing. If the coil itself is rotating, that theta is changing. So, that is why I am moving out from this theta. You have to find out delta t. Okay. So, delta t is equal to A dB upon this induced EMF, that is A dB upon induced EMF. Fine. So, now let us try to put the values. A is 10 into 10 to the power minus 2 into 10 into 10 to the power minus 2. Fine, because it is the side of a square. So, area of a square is L into L. So, A is equal to 10 into 10 into 10 to the power minus 4. We have to convert in meters. Fine. And this value is how much and this value is how much? So, it is basically I should write it down like B2 minus B1, but there is no point of saying 20 minus 0. So, directly I can use 20. Fine. Otherwise, if other value is given, then max value minus minimum value, then whatever the result you are getting, that you have to use. Fine. So, over here it is going to be 20 itself. So, dB is equal to 20. And what about this value? Fine, this induced EMF. So, induced EMF is 10. Now, put the values and solve it. Fine. So, I think I should simply put the values after putting values, we get delta t or dt as 2 2 millisecond. Fine, 2 milliseconds. So this problem is essentially based upon your that previous result which just some time back I mentioned for question number 1, and then basic calculation and result is in front of your eyes. Fine. Electromagnetic induction chapter, students, is very important, whether JEE exam, whether your NEET entrance exam or anything else. But if you have any difficulty in the concepts, please go through with our previous videos of theory, and I hope you will find yourself in a much comfortable position. Fine. So here comes the number for the next problem, and this problem is question number 3. I am sure many of you must have solved these type of questions. Up to some extent, yes, it's a revision of short of this concept, but this concept is so important that almost all type of competitive exams, if a setter, examination paper setter is putting a problem from electromagnetic induction, then he or she can't stop herself or himself by using these type of questions. So beautiful questions. So let's try to understand. Here simple integration is approach is usable. That's it, nothing difficult over here. The magnetic flux, moment magnetic flux terms comes into picture. You should try to recall phi b. Okay, that is magnetic flux. Fine. So magnetic flux through a stationary loop with resistance R varies during interval of time t as phi is equal to AT t minus t. Fine. The heat generated during this time neglecting the inductance of loop will be how much? Now first we should try to understand the problem. Okay, let's imagine this is a loop, square loop, circular loop, rectangular loop. Concept is ultimately going to be same. Okay, now it is placed like this. Fine. Magnetic field lines are passing this way, say for example, fine, towards this direction. Now if magnetic field lines are constant in magnitude, no effect. Okay. If this rectangular loop is constant, not changing, then theta is fixed, no effect. Even the area is not changing, remain constant. But over here what is given? That flux itself is changing. It means magnetic field lines are changing. So accordingly some changes are taking place, and then induced EMF will come into picture, and because of that induced EMF, induced current will flow, and when the induced current will flow, then heating effect I would like to mention as H is equal to I square RT. So basically in this question they are saying you go back to class 10th and calculate this heat energy, heat applicable in this loop. Fine. So what we will have to understand over here, let's try to erase this. Step by step I am going to provide you the solution. Fine. Is equal to d phi b by dt. One thing you can realize that this formula is very important for electromagnetic induction, and repeatedly close to the question I am explaining it. Fine. So that every time the question should be in front of your eyes. Okay. So this basic formula we are going to use, and what is the value of phi? It is given over here, AT t minus t. So let's try to put the value of phi b over here. Okay, in this particular problem. So heat H is equal to how much? I mentioned I square RT. Let's change this formula slightly and mention it E square upon R dt. I think you should not get confused. So let's say this way. Fine. What is the meaning of this? D phi by dt. So square of that ultimately. So you will get H is equal to A T. I am not doing anything, simply this term I am putting, fine. So, AT minus 2AT whole square, fine. AT minus 2AT, AT minus 2AT, okay, this is small t, fine, whole square divided by this R resistance into dt. Now, once after getting this relation, what we will do? We will make it square, break it, put it, and then try to integrate it. Fine. So, over here, what you will get? You will get a square plus b square minus twice ab. So, first let me write down this. And this time, after taking this value out, even if I move out from this space, I hope you will not mind it. Fine. So, the result is going to be a square t square minus twice a 2 2s are 4, I think, yes, it is going to be a square plus b square, that is 4a square t square, a square plus b square minus twice ab, that basic formula, minus twice ab, that is 2 2s are 4, a square t minus 4a square t into t, fine. So, ultimately one term, two term, three term, you have to integrate with respect to time. Over here the resistance is something which is constant, so please put it outside, fine. So, let me allow to mention this term over here, integrating these terms, with respect to t, keeping R out as constant, fine. Integrating these terms with respect to t, keeping R out as constant, what we will get? The heat generated, H is equal to a square t cube upon 3R, fine, a square t cube upon 3R. So, if we take a look of this term over here, then a square t cube upon 3R, so a is the correct answer, fine, because over here it is a square only, not t square. What exactly I am skipping over here? Let me mention it. You are preparing for JEE mains, mathematics is your one subject, fine. So, integration why it is important? Reason being, few of you may think, sir, what's the point? Simply mention this, then you mention integrating these terms, and then directly you are showing the result. If you are preparing for medical entrance exam, then it was my duty to explain all these terms, but mathematics is your subject, that's why I am not explaining it, fine. Integration, differentiation, you all are learning, so that's why deliberately I skipped that explanation over here. And at any point of time, if you are finding this discussion difficult, please revise your basics of integration and differentiation, but don't do it in the knowledge of the mathematics teacher, otherwise he will not find it good, fine. Basic results you must have to be comfortable. Then it comes this question. Actually, few years back this question was asked in JEE Advanced exam. Now, why I picked this question? Reason is simple. Sometimes few questions they love to ask so that they can check how much comfortable you are in calculations and also in visualization. Even in this year's question paper, with which JEE mains, with which we also presented explanations and keys and all these things, there were few questions of this category, fine. So, let us try to understand what exactly the problem is. In a cylindrical region having radius r, magnetic field varies with time as b is equal to a plus bt. Okay, a is some constant, b is some constant, but here this time is creating a problem. Okay, OPQ, this triangle OPQ is a triangular loop made up of wire having resistance per unit length lambda. Now find the current induced in the loop. Induced, I think I should use this different color chalk. Induced. So what exactly required over here? Required is this induced electromotive force. Only this will give you induced current. Now what exactly the basic idea of the problem? Let's say I have a wire, fine, and with the help of a wire I created this type of shape, triangular shape, and then I place this triangular shape in a cylinder. Basically this is upper view, you are watching the cylinder from the top, that is why you are getting only this circle, it is not circle. This triangular shape loop is placed inside this cylinder, and inside the cylinder magnetic field is varying. Then you have to calculate the current induced. So first you have to calculate this value of induced electromotive force, and accordingly we have to find this value of current. Now what is important over here? Important is we don't know what exactly the length of this loop. So with the help of this angle and with the help of the idea of the Pythagoras theorem, we will try to find out the length, and as given in the problem, per unit length have resistance lambda. So let's say the entire length of this wire is 10 units. So total resistance is going to be how much? That is 10 lambda. So what will be the value of the current? Let me allow to write down V is equal to IR result. So what we should mention over here? V, that is capital E, is equal to I into this 10 lambda. So I is equal to this capital E upon 10 lambda. So this is going to be the approach for this problem. Now let's try to find out the solution. And in these type of questions, if any point of time you are finding that the explanation which I am giving is not sufficient for your understanding, you can take the look of your e-books also, because we are providing detailed solution in those e-books. Fine. Repeatedly I am mentioning it so that you cannot forget it. From triangle OPQ, fine. From triangle OPQ, PQ means this P and this Q. What is the length of this PQ? That we are going to discuss, and also what is the length of OP? That we have to find out. So this PQ is equal to root 3R. Why? What is the value of this angle? And I am not mentioning the value of this angle in terms of tan theta. Fine. So let's say equation number 1, and OQ is equal to 2R. Let's say equation number 2. Now we have the value of this term, we have the value of this term, fine, in terms of radius R. Ultimately, if we wish, we can find out the PO value in this triangle, fine. So from triangle OPQ, PQ is equal to root 3R and OQ is equal to 2R. So resistance, yes, resistance of loop OPQ is how much? Is lambda, fine, because we don't know the exact length. So what we will do? Add this, add this, add this, and multiply by lambda. I think I should use a different color chalk to show you this. That is lambda R plus 2R plus root 3R. Anyway, not a difficult thing, very simple. Fine. So this length, and this length, R plus 2R plus root 3R. So how much it's going to be? take r common. So 1 plus 2, that is 3, 3 plus root 3, fine. So let's write down this value over here using this diagram. So r, and don't get confused with this r, this is resistance and this r is the radius. Actually in this diagram when they asked the question, it was the term which was slightly confusing. So that is why I am using this r resistance. So it is going to be how much? R lambda 1 plus 2, 3, 3 plus root 3, fine. So what we can say, 3 plus root 3, okay. Now in this relation take root 3 common. So root 3 lambda r, how much it is going to be? It is root 3 in this term plus 1. Basic mathematics, but because in last 1, 2, 3 problems I not devoted that much time on mathematics, assuming that you people have mathematics as a subject. So I hope few of you may mind it that why the teacher is not explaining simple terms, but you just consider yourself how simple terms we are using over here. So explanation or calculation of these terms not required. Then I induced, fine, I induced is equal to A by R, the same result, dV by dt, fine. Now over here what you have to do, you have to use this R resistance exactly over here. What is the A? Now A is something that you have to use the basic formula of area of this triangle. I am not going to interfere in your that approach, simple. And then dV by dt. What is the variation in B? A plus bt. So ultimately A is constant without t, B is constant with t. So we have to take care of these terms, fine. So I induced is equal to, putting aside this A R term, what I am going to mention is that is d by dt of this A plus bt. I don't think it's going to be a difficult task for you. dA by dt 0, dB by dt, that is only this B, fine, because dt by dt that is going to give you 1. So ultimately this value already I explained, A is the area, fine, this triangular formula, resistance value I mentioned in front of you, and then in differentiation of this term. So ultimately you will get it as pi b r root 3 minus 1 upon 12 root 3 lambda. Just put the values and get the correct answer, fine. Just put values, then this A is the correct option. A is correct option. You can visualize one thing by watching these questions, that yes, from this electromagnetic induction chapter, questions are not very difficult, but obviously some sort of integration, differentiation or calculation is required. Now let us say someone is unable to recall the formula of area of this triangle, meaningless question, and this is something which you are supposed to learn in class 9th, and that is why deliberately I skipped it, because if you are unable to recall these basic results, then there is some problem, sorry to say, but yes, there is some severe problem in your approach. Please don't do like that, fine, at any point of time. So now let us move ahead for the next problem. This problem is only a big problem, as such this question is simple one. How? Let me decode the question step by step. Fine, I don't want to come between you and your question, so let me allow to stand slightly away from your question. I hope the entire question is visible to you, so just listen my words and put your eyes onto this first term, that is the figure shows an isoscale triangle. Just take a look of my hand, this isoscale triangle 90-degree. Wire frame, basically it is made up of wire, let us say copper or anything, with apex angle equal to pi by 2. Fine. The frame starts entering into the region of uniform magnetic field, this. Here B not changing, theta not changing, but area is changing. Why? When this much portion inside some amount of induced EMF, when this much portion inside some more amount, when entire portion inside some different induced EMF. So that's why you can say the problem based upon change in area. Okay. The frame starts entering into the region of uniform magnetic field B with constant velocity V at any time t is equal to 0. Means when we started observing this experiment, at that point of time we start our stopwatch. Longest side of the frame is perpendicular to the direction of the velocity. Now they make this problem more simple. Why? Just take a look. This longer arm is moving like this. Fine. Perpendicular to the velocity, direction of the velocity. If I is the instantaneous current through the frame, instantaneous why? See, as this triangular loop will keep inside, so what will happen? Induced EMF will change. Accordingly, your I will also keeps on changing. So if I is the instantaneous current through the frame, then choose the correct answer which is showing the correct variation of I with respect to time. Now, there are two approaches in this question. If you are comfortable with the concepts, then just by watching this line, you can say correct answer is this. How? Okay, take a look. Velocity is constant, uniform variation in the area. Uniform variation in the area means induced EMF uniformly will enhance. More the area in, more the induced EMF, so more the amount of current. So direct relation is as the wire loop keep on entering with increment in the time, the current will increase. Moment you say velocity is changing, then your this graph is going to be changed, and C is the correct answer. So this is one approach where you need not to pick even a pen. Just by reading the question properly, you can say this relation. But few of you may say, we don't like this type of approach, we love to solve lot of things, while it is not advisable in examination hall. Because in small amount of time you should try to find out the correct solution. So for all those people, I is equal to B upon A. Is it like that B is changing? No. Is it like that this area is changing? Yes. So how exactly this variation? dA by dt. Means area is changing with respect to time. So at any time I is equal to B upon R d by dt of this variation of the area. So inside you should simply mention it is uniform. Fine. So if it is uniform, so rate of change is also going to be uniform. B is constant, R is constant. So what I should say? I should say I is directly proportional to T. So now only this graph is correctly representing this variation. Don't you think it is something, this type of relation, Ohm's law? So over here situation is simple. So either way, I mean, if you want to love some calculation, you can do these steps. If you don't like, and if you are unable to, if you are able to understand just by watching this catch line, constant velocity. Very good. Just 10 seconds, correct answer is with you. So students, what my suggestion is, these 5 problems are definitely force to think you, to revise you, and which is our exact purpose. In future, very soon we will definitely come back with more set of good questions. Till then, keep revising, keep enjoying, and be focused. If you read these type of problems carefully, definitely you will save lot of time. Fine. So with this positive note that please keep revising, keep watching these videos regularly, try your best from our side. Best of luck. Till then, take care. Bye bye.